Phase shift. You should be familiar with the graphs of y equals sine of x and y equals cosine of x, and how they can be stretched to change the amplitude and period. In this lesson, we will shift the wave graphs both vertically and horizontally. The horizontal shift is called phase shift. In this example, the function 2 times the sine of x plus 3 is the sine wave with amplitude 2 shifted up 3. We begin with the standard sine wave. We then make the amplitude 2, and finally the plus 3 will move the graph up 3. The tops of the waves will move from 2 up to 5, and the bottoms of the waves will move from negative 2 up 3 to 1. The center line of the wave is at 3. The key points on the final graph have the standard x values of 0, pi over 2, pi, 3 pi over 2, and 2 pi, and y values 3, 5, 3, 1, and 3 respectively. The other addition we need to be concerned with is the constant c added inside the parentheses to the angle. Constants added inside the parentheses will shift the graph left and right. For sine and cosine waves, this shift is called the phase shift. In this example, we have a sine wave whose frequency is 4 times that of a standard sine wave, and the pi over 4 will shift the graph horizontally. Again, we begin with a standard sine wave. We can then adjust the period. The period is 2 pi over b, which in this case is 2 pi over 4, or pi over 2. The red graph goes through a full wave every pi over 2, and makes 4 full waves in reaching 2 pi. The pi over 4 will shift the graph horizontally. Again, this shift is called the phase shift. One way to find the phase shift is to find the value for x that makes the angle 0. In this case, the angle is 4x plus pi over 4. We set the angle equal to 0 and solve for x. In this case, the phase shift is negative pi over 16. This will cause us to shift the graph pi over 16 to the left. Returning to the unshifted graph, the period is pi over 2. To mark the standard points, we next find the quarter marks by dividing the period by 4. The quarter marks happen every pi over 8. The sine wave is at the top at pi over 8, back to the middle at 2 pi over 8, or pi over 4, at the bottom at 3 pi over 8, and back to the middle at 4 pi over 8, which is pi over 2. Recall that we found the phase shift to be negative pi over 16. To help us mark the x-axis, it is convenient to find a common denominator between the quarter marks and the phase shift. In this case, the common denominator is 16. We can then mark the x-axis every pi over 16. Let's restate the key points on the sine wave using the denominator 16. The wave hits the high point at 2 pi over 16, back to the middle at 4 pi over 16, down to the bottom at 6 pi over 16, and back to the middle at 8 pi over 16. We now need to shift the wave pi over 16 to the left. The start of the wave moves to negative pi over 16, then to the top at pi over 16, back to the middle at 3 pi over 16, down to the bottom at 5 pi over 16, and back to the middle at 7 pi over 16. We can extend the wave further if we wish. Let's review the process for drawing sine and cosine waves. First, mark the y-axis as follows. D determines the vertical shift, which is where we place the center line. From the center line, go up and down according to the amplitude. Then we mark the x-axis. First, find the period, 2 pi over b. Divide by 4 to get the quarter marks, and find the phase shift by setting the angle equal to 0 and solving for x. Next, find a common denominator between the quarter marks and the phase shift and mark the x-axis evenly. You can then mark the reference points for the unshifted graph and then use the phase shift to move the graph left or right. Here is a full example. It is a cosine wave, so our instinct is to follow the pattern top, middle, bottom, middle, top, except this cosine wave has a negative sign in front, which flips the graph top to bottom, so it'll go bottom, middle, top, middle, bottom. It has an amplitude of 6. A vertical shift of 2. So the center line will be at 2, the top will be 6 above 2, which is 8, and the bottom will be 6 below 2, which is negative 4. The period is 2 pi over b, which in this case is 2 pi over 2, which is pi. The quarter marks happen every pi over 4. To find the phase shift, we set the angle 2x minus pi over 3 equal to 0 and solve for x. The phase shift is pi over 6. We find a common denominator between pi over 4 and pi over 6, which is 12, and we rewrite the quarter marks and the phase shift in terms of pi over 12. When we mark the x-axis, we'll mark it every pi over 12. You may wish to jot down this information to refer to as we move ahead to drawing the graph. Let's mark the y-axis first. The center line is at 2, the bottom at negative 4, and the top at 8. We mark the x-axis every pi over 12, emphasizing the quarter marks at pi over 4, which is 3 pi over 12, pi over 2, which is 6 pi over 12, 3 pi over 4, which is 9 pi over 12, and pi, which is 12 pi over 12. The reference points for a negative cosine wave are placed at the bottom, middle, top, middle, and bottom. We can then draw the unshifted graph, extending the wave as far as we wish by following the pattern. Finally, we shift the reference points by the phase shift, which was pi over 6, or 2 pi over 12. We can then draw the final graph. Now, let's go backward. Given the graph, can we find an equation? First, we need to decide on the general form. We have several choices. Perhaps we can choose a section that looks like a standard cosine wave. The middle points are at a height of negative 1, so d is negative 1. The graph hits its peak at 1 and its valley at negative 3, which is a total distance of 4. The amplitude is half the distance from the bottom to the top, which in this case is 2. B is determined by the period. One full wave begins at pi over 12 and ends at 9 pi over 12 for a wavelength of 8 pi over 12. 8 pi over 12 is 2 pi over b, so b is 3. Finally, we know the phase shift is pi over 12. The phase shift is the value of x that makes the angle 0. In this case, the angle is 3x plus c, so we have the equation 3x plus c equals 0, and know that the x value should be pi over 12. So we solve the equation 3 times pi over 12 plus c equals 0, giving c equal to negative pi over 4. This is one possible way to write the equation for the graph. Let's do this again, this time focusing on a portion of the graph that looks like a standard sine wave. The analysis of the amplitude, vertical shift, and period are the same as before. The amplitude is 2, the center line is at negative 1, and the period is 8 pi over 12, so b equals 3. This time, the phase shift is negative pi over 12, so negative pi over 12 is the value for x which makes the angle 0. We need to solve 3 times negative pi over 12 plus c equals 0, which gives c equal to pi over 4. Let's try it one more time with an upside down cosine wave. Again, the amplitude is 2, the center line is at negative 1, and b equals 3. The phase shift is negative 3 pi over 12, So 3 times negative 3 pi over 12 plus c equals 0, making c equal to 3 pi over 4. This gives us the equation of the graph. You can find many more equations for this graph. All you need to do is find one complete wave and figure out the values of A, B, C, and D from that wave. To recap, D determines the center line of the wave. The amplitude is then used to find the tops and bottoms of the waves. The period is 2 pi over B, which is cut into 4 parts to determine the reference points. To find the phase shift, find the value of x that makes the angle 0.